Welcome to Get Smart with Stanford, where learning gets easier, smarter, and fun. We are tackling grade 11 trigonometry step by step today. This episode is proudly brought to you by Royal Gamazine, giving your home the royal touch with stunning Gamazine and glamour coat finishes. For inquiries, contact them on the number that is appearing on your screen right now. Let us try to answer the following questions. Given that tan theta equals 3 over root 7, where theta is the element of 90 degrees and 270 degrees. Determine using a diagram the value of sine theta and the value of 4 cos square theta minus sine 180 degrees plus theta. Given the value of tan theta, we will draw our right angle triangle like this. We know that tan theta equals opposite over adjacent. Therefore, we will put our values, as you can see, in relation to angle theta. Now we use the easiest method, which is the Pythagoras theorem, to find the longest side hypotenuse of this right triangle, and the value of the longest side r equals 4. Now that our right triangle is set with all values, we can answer our questions. Sin theta equals opposite over hypotenuse. Therefore, sin theta equals 3 over 4. Check on the right triangle. And the next question, 1.2, 4 cos square theta minus sine of 180 degrees plus theta. To answer this in an easier way, we will need to draw a Cartesian plane and apply a mnemonic all students take coffee. This mnemonic helps us remember that all trigonometric identities are positive in the first quadrant. Sine is positive in the second, tan in the third, and cos in the fourth quadrant. Sine 180 degrees plus theta. That means we are working in the third quadrant, where sine is negative because we know that tan is positive in the third quadrant. Since sine is negative in the third quadrant, then we have 4 cos square theta minus negative sine theta. We now apply the SOHCAHTOA to get our numerical values and calculate to get 10 over 4. If the examiner instructs you to leave your answer in decimal form, you will calculate to get 2.5. In the following diagram, T with coordinates x and 15 is a point on the Cartesian plane such that OT is equal to 17 units. Point P with coordinates minus 2 and A lies on the OT. K is a point on the positive x-axis and angle TOK equals theta. Here is the diagram with all the points as we have read. And these are the questions that need to be answered in relation to the statement and the diagram. All right. To solve these questions, we'll start by looking at what's given. Then we'll sketch or extract the right triangle from the Cartesian plane and find the missing side x. Finally, we'll apply the Pythagoras theorem to calculate the value of x, which comes out to be minus 8. Alright, for 2.1.1, we've already calculated the value of x and found that it's equal to minus 8. So here we simply write minus 8 as our final answer. Moving on to 2.1.2, finding the value of tan theta. That is pretty straightforward. We know that tan theta equals opposite over adjacent. So that gives us tan theta equals 15 over minus 8. For 2.1.3, here we are dealing with cos of 180 degrees minus theta. This angle lies in the second quadrant, where cosine values are negative. So we are going to have minus cos theta. And when we substitute the values, we get 8 over 17. 2.1.4 is also quite simple. We just use the numerical values from our right triangle. Then our final answer here is 225 divided by 289. And finally, for this particular question, number 2.1.5, since point P lies on the line OT, the gradient of OP is the same as that of OT. Using the gradient formula, as you can see on the screen, we substitute, and thereafter equating the two, we find that the value of A equals 15 over 4. In question number 3, we are asked to simplify this trigonometric expression without using a calculator. So we first write it down clearly or copy it as it is. It is much easier when you start by simplifying each trigonometric ratio separately using the special angles and identities. So in this case, we would have sine of 120 would be equal to 180 degrees minus 60 degrees. And we know that from the special angle, sine of 60 degrees equals square root of 3 divided by 2. Cos of 210 degrees. This would be 180 degrees plus 30 degrees. And since it's 180 plus, then that is in the third quadrant and cos is negative. So we'll have negative cos 30. And we know that the value of cos 30 in the special angles is square root of 3 divided by 2. So we would have to put that negative to signify the quadrant. Tan of 315 degrees would be equal to 360 degrees minus 45 degrees. And 360 minus, that is in the quadrant number 4, and that's where tan is negative. So we would have negative tan 45 degrees, which would give us minus 1 from the special angles. I opted to keep cos 27 degrees that way because I looked at the denominator and saw sine 63 degrees, and that is sine of 90 degrees minus 27 degrees, and that would change to cos 27 degrees. The cos 27 degrees on the numerator would cancel out the cos 27 degrees on the denominator. And lastly, we have cos 540 degrees. This is 360 degrees plus 180. This would give us cos 180, and we know from special angles that cos of 180 degrees equals negative 1. And what is left for you to do is just to work on the numerical values until you reach the final answer of minus 3 over 4. That should be much easier for you if you have reached and understood up to this stage. All right. In number 4, we are asked to prove the identity. We'll start by working on the left-hand side, LHS. And remember, it is always important to mention which side you are working with. So here I've clearly indicated LHS, which is left-hand side. Since we're subtracting fractions, our first step is to find the lowest common denominator, which we get by multiplying the two denominators together. Next, we use the Pythagoras identity. That is sine square theta plus cos square theta equals 1. From this, we can express cos square theta as 1 minus sine square theta. After substitution, the plus 1 and the minus 1 cancel out, leaving us with just sine theta plus sine square theta. From here, we simplify. Some terms cancel out nicely, and we are left with sine theta divided by cos theta, which is equal to tan theta. And that matches out our right hand side, which is tan theta. So we have proven the identity in this case. Now let's move on to question number 5, where we need to find the general solution of 3 sine x equals 2 tan x. First, let's remember that tan x equals sine x over cos x. So we'll substitute that into our equation. That gives us 3 sine x equals 2 times sine x over cos x. Now, to make this equation easier to work with, we can multiply both sides by cos x. But we must note that cos x must never be equal to 0, because that would make tan x undefined. So after multiplying through by cos x, we get 3 sine x cos x equals 2 sine x. Next, we can see that both sides have sine x. Let's factor it out. We will find sine x into 3 cos x minus 2 equals 0. From there, we can see that we can set each factor equals to 0. That is sine x equal to 0. And our x equals 0, 180, 360, or in general, x equals k times 360. K is an element of integers. And that's it for today's tutorial. But before you go, I'm leaving you with a quick challenge to test your understanding. Try simplifying this expression without using a calculator. Let's see how well you've mastered today's lesson. Don't forget to subscribe to the channel and share this video with your friends and classmates. I hope you found this lesson helpful. If you have any questions, feel free to reach out to Get Smart with Stanford, either by email or WhatsApp. Until we meet again, keep learning, keep practicing, and always remember to get smart with Stanford at all times. Goodbye.